So when we find the domain of rational functions, a rational function is a polynomial in the numerator, a polynomial in the denominator. So when we find the domain of such a function, all we need to do is think about what makes the denominator equal to 0. And when we solve this equation, we get x equals 3 and x equals 4. So the domain is all real numbers except the numbers 3 and 4. Okay. Notice that x minus 3 and x minus 3 can get cancelled. But when x is equal to 3, you're not allowed to cancel it, because you're not allowed to cancel a 0 with a 0 and call it a 1, right? So just look at the denominator and figure out where it is undefined. And the same thing in the first problem, we need to find the points at which the denominator is equal to 0. And notice that it's impossible to factor this equation. We have to solve it only by the quadratic formula, minus b plus or minus the square root of b squared minus 4ac divided by 2a. So that is equal to -1 plus or minus radical -3 the whole divided by 2. Okay, so this is an imaginary number. What does that tell us? Because there's a negative under the square root, it's an imaginary number, and that tells us that there is no real number for which x squared plus x plus 1 equals 0, which means your domain is all real numbers.